for joining us for the circumference and area video. If you've watched any of the other videos, it is possible that you have seen some of the same examples on there, and that is okay. It's always good. Never hurts to see some more than once. Remember, as always, as you are taking notes, if I am moving too quickly, feel free to hit pause to copy down in your notes what you need to copy down. Today, our essential question is, how do you find the circumference and area of a circle? We will also be adding to that, how do I find the radius and diameter of a circle when the area is given? And we're also going to touch base a little bit on sectors of a circle. How do I determine the sector of a circle at the very end? A few of the pieces of information that we need to know and remember, first of all, is what is the diameter? We need to know that the diameter is the distance across the circle. A key piece that we do need to add to this is the distance across a circle going through the center point. Going through the center. There are lines that go through a circle or go across a circle that are not the diameter. The key is the diameter needs to go through the center. The radius. The radius is the distance from the center of the circle to the edge. It's the distance from the center of the circle to the edge. Circumference is the distance around the circle. And the formula for circumference is pi times the diameter, or pi times 2 times the radius. 2 times the radius is the same thing as diameter. Last but not least, we have area. Area is the amount of space inside of a shape. Area equals pi r squared. One last point that we should point out is the sector of a circle. Sector of a circle. And the sector of a circle is just, we could define it as a partial area of a circle. It's where we're talking about maybe only having a semicircle or having 1/3 of a circle and having to find the area of just that part. All right, so let's get to it. This is going to be a longer video than normal just due to all the calculations. I'm going to trust that you plug into your calculator the calculations. I will write them down for you, but if you want to verify my calculations, that would be great. For each of these, we need to find the circumference and the area, and then we need to round it to the nearest tenth. I like to stay and lay out some of my information first. First, I notice that this one here gives me a diameter, and my diameter is 15.5 centimeters. I also then can determine what my radius is. My radius is going to be half my diameter, which is going to be 7 7/75 centimeter. I, from there, can find the area. I know the area is going to equal pi r squared. And I can also find my circumference, and I'm going to choose to use the diameter pi formula for that one. So as I go through my first formula here, all I'm going to do is plug in the values that I know. I know the radius, so my area equals pi times my radius, 7.75, quantity squared. And when I plug all of that into my calculator, I am going to get a total of 188 6/10 centimeters squared. Remember, you have to do order of operations and square this first before you multiply it by pi. All right, to find my circumference of this circle, my circumference, I just need to take the diameter times pi. And when I do that, it would be circumference equals 15.5 times pi. And simply put is 48 67/100 centimeters. Notice that circumference is not squared. It is just a simple distance going around. Using these same formulas in part 2, I'm still going to define my diameter and my radius. In this example, I'm given the radius of 10.9, so I have to find the diameter. And when I find the diameter to this, it's going to be 21.8. I can then come back and use my different formulas. I know that area equals pi r squared, which is the same thing as pi times 10.9 squared. In my calculator, I'm going to calculate this first, do the exponents, and multiply it by pi. And I would find out that my area is 373 and 6/100, I'm running out of room, feet squared. Then I have to come back and do the same thing in order to find my circumference, except I need to use a circumference formula. And for this example, if I didn't compute what my diameter was right away, I could just use that other formula where it would say 2 times pi times the radius. So it would be 2 times pi times 10.9. And then when I compute all that out, I would get 68 and 45/100 feet. Again, do not put a squared here because we don't need a squared, it's just a distance around. All right, here we go. In this example, we're asked to find the radius and find the diameter of each circle. So we need to look at the information we have. The first piece of information we have is the area of this circle. So just like every problem, I'm going to write down things that I know. I know that area equals pi r squared. I also know that area equals 169 pi. Now what I'm going to do is use substitution. I'm going to take this 169 pi and plug it in for this a, just like we would have done on a problem from Unit 3 or Unit 1. I'm going to take 169 pi, put it in for this a, and I'm going to set it equal to pi r squared. In this example, I'm trying to solve for the r. So to get the r by itself, I need to divide by pi. And in all honesty, that's a great thing because by dividing by pi, this goes away. And that's good because it was stressing me out just a little bit. So now I have 169 equals r squared. I then have to go back to my knowledge from Unit 2, where we talked about square roots and perfect squares, and remember, oh yeah, the inverse or opposite of a square is a square root. So I take the square root of both sides, and I find out that 13 equals r. I could stop here, but then I'd get the answer wrong, because it asked me to find the radius and the diameter. I remember that radius only goes halfway across the circle. So if I wanted the whole thing, I have to double that number. And so my answer for the diameter would be 26. And then I need to make sure that I add my labels. So it'd be 13 millimeters and 26 millimeters. I'd like you to hit pause and try number 2 on your own. And when you come back, see if you got the same answer as I did. All right, so for this answer, I'm just going to show you how I set it up. I had 25 pi equals pi r squared. I divided both sides by pi. And then I ended up with 25 equals r squared. I took the square root of both sides. And I found out that 5 equals r. After I had 5 equals r, I know that I could get the diameter, which would be double that, which was 10. So I know that the radius was 5 feet and the diameter was 10 feet. If you got that answer correct, give yourself a nice little pat on the back. All right, so these questions are the same. I want you to please pause and see if you can answer the questions. I'll read them for you before you pause. If the coin has an area of 736 millimeters squared, what will the radius be? See if you can get one of those answers. And then this one, the area of a circular floor carpet is 1,243 and 47/100 centimeters squared. Find the radius. All right, now that you've paused it and you've come back, the answer to this first one was 15 and 31/100 millimeters. That was the radius. And for the second one, it was also letter B, in that it was 19 and 9/10 centimeters. If you got that, go ahead and give yourself a gigantic pat on the back. All right, next question. So we have Mr. Dummer here, and he's going to have a circular pool in his yard, but he wants to give a walkway around it. We know that the pool has a radius of 12 feet, and they want a 4-foot walkway around the pool. I want to know what is the area of just the walkway. So here's a diagram of that picture of what's going on. And essentially what I'm asking you is, what is the area of just this white part? Well, what I want you to see is that there are two circles here. There's the outer circle, and there's this inner circle. I'm going to reference it as the large circle and the small circle. So what I know is I need to take the area of the large, and I need to subtract the area of the small. And if I take the large one and subtract the small one, just like I was cutting it out with scissors, all I'll have left over is this little white pathway that we want. So how do I find the area of the large? Well, I need to, again, to find area, say pi r squared. In order to find that, then I'm going to take the radius of this. Well, the radius of the white part is this 4 feet, but also the 12 feet here. So the radius to this one is actually 16. So this is going to be pi times 16 squared. 16 squared, if I remember correctly, is 256, but I am going to check that really quick. All right. So area equals 256 pi on the large circle. Now what I need to do is I need to find the area of the small circle. To find the area of the small circle, I'm going to take the same exact steps. I'm going to say area equals pi r squared. And then I need to say, well, on this little circle, the r is only 12. So it's going to be pi 12 squared, which is 144 pi. So now I need to take the area of the large one and subtract the area of the small one. If I had 256 pi's and I subtracted 144 pi's, I would be left with 112 pi's. Now I need to know what this answer is in actual feet. So I multiply through by pi, and I have 351 and 68 feet squared. That is the remaining part of that pool. What I'd like you to do is see if you can find the area to this one. Pi r squared. Now you're freaking out because I haven't lowered this. So let me lower that. There's the other piece of information you need. So I want the area of the shaded region. Go ahead and pause, compute it, just like the walkway problem, and come back when you're done. All right, so here I am with the large circle. My area for this one is going to be pi times 5 squared, which is going to give me 25 pi. I got the 5 because, again, this is diameter. The radius would only be half of that. For the inside circle, area is going to equal pi times 3 squared. Whoops, I gave you the answer there. 5 times 3 squared, which is 9 pi. So then what I have to do is subtract these two. I'm going to take 25 pi, the larger circle, and I'm going to, get this out of the way, and I'm going to subtract 9 pi from that. And when I do, I get 16 pi. When I multiply these two together then, I get 50 and 24 feet squared, and that would be the remainder of just the inside area there. If you got that answer for yourself, go ahead and give yourself a pat on the back. All right, I am going to have you in a minute pause the video, but I want you to notice this one is just slightly different than the last one, but I want to see if you can get it. So I want you to pause the video and see if you can solve it. All right, so what do I have going on here? I need just the green region. Seems pretty simple. So the first thing I'm going to do is find the area of the green. And actually we'll color code this because that would be a nice touch, right? So let's take a green one here. And I'm going to take the area of the green. So area is going to equal pi r squared. I know that the radius of the green one, if this whole thing was green, would be pi 12 squared. I know that 12 squared is 144, so this is 144 pi. I then know that I have to find the area of the yellow one. Let's see how well this shows up. Ooh, that's really bad. We're going to turn that to red. So this is going to be the area of the yellow one, which again is pi r squared. Now, what do you notice here? I notice that from here to here is going to be the same distance as it is from here to here, which is 5. So if this whole thing is 12 and this much is 5, it means that just this yellow part here is 7. So in that case, that is my radius. When I multiply those, I get 49 pi. Again, I want just this green region, which means I need to subtract or cut out this yellow region. So I'll have 144 pi minus 49 pi. When I get that, I get 95 pi. And when I multiply the two of those together, I get 298 and 45 hundredths feet squared. That one was a little tricky. If you happen to get that one right, go ask your parents for some sort of reward, whether it's a quarter or a handshake or a, hey man, you're awesome. All right, this one. We need to find the area of the circle in terms of pi. What does that mean? Well, simply stated, looking at all of our answer choices, pi needs to be in the answer. So I know that the area of a circle equals pi r squared. I know that the radius of this circle is 7. So I know this equals pi 7 squared. I know that 7 squared is 49 pi. When I solve it in terms of pi, it means I need to have pi in my answer. This has pi in the answer, which is right here. So the answer is C. Easy enough? All right. Sector of a circle. Notice that the sector of the circle is just this shaded part. It's only part of it. And in this case, it tells me it's 1/4 of that circle. So how do I find the area of just this part? Well, it's easy. Find the area of the whole thing and divide it by 4. I'm going to divide it into 4 parts. So if the radius of the circle is 4, I know that area needs to be pi r squared. So that would give me pi times 4 squared, which is 16 pi. So the area of this whole thing is 16 pi. For those of you who don't want to solve it in terms of pi, you could take 16 times 3.14 and you would get an answer of 50 and 24 hundredths. These are the same thing. However, when I look over here in my answer, notice that pi is in all of them. So I'm probably going to want to keep hold of that. Now, remember, this is the area of the whole circle. How much do I want? Just 1/4 of it. So I need to divide it into 4 pieces, which is simple. I'm just going to divide this by 4. If I take the 16 and divide it by 4, I get 4 pi, and that would be the correct answer. I want you to take this skill and take this knowledge and try to compute this one. Go ahead and pause. All right, after you computed all of this, you divided into 3 pieces, and you probably noticed your answer wasn't over here. But remember, this said 2/3. So after you divided it into 3 pieces, you had to multiply it by 2, and your answer should have been C. If you got that one, give yourself a nice pat on the back. All right, what do I do when I am not told what fraction of a circle the shaded area is from? Well, what do I know? I know that if I have the radius of a circle, which is in this case 5 centimeters, I can find the total distance around. Remember, the total distance around is the circumference. So in this case, if I was to find the circumference of this, circumference equals 2 pi r. So it equals 2 times pi times 5, which is the same as 10 pi, which is the same as 31.4 if I did that way. Now, that is all the way around. If I was to complete this circle, and it's not really going to be a circle due to the size on my screen and my drawing skills, this whole thing would be 31.4. But I have 6.28 right here. So what I can do to figure out what part of the whole thing this is, remember part over whole, is I'm going to take 6.28 and put it over 31.4. 6.4, part over whole. Now I look at this and I can't really tell that it can be reduced, but I can see that both of these can be reduced by 2. But I'm also, just for the off chance, going to just take this 31.4 and see if I can turn it into some sort of unit rate. Can I take this 31.4 and divide it by 6.28? I can. When I take 31.4 and I divide it by 6.28, I get 5. So what that tells me is that 6.28 goes into 6.28 once, and it goes down here 5 times. It's basically like I reduced a fraction by 6.28. Why is this important? This is where all the steps come in. Remember, the first step we found was the circumference to tell me how far around it was. Then I had to take this and divide it to figure out, well, what part of the fraction is that? Now I need to go back and find the area of the whole thing. The area of this whole thing is going to be pi r squared. I know the radius is 5, so it's pi 5 squared. I know that 5 squared is 25, so this is 25 pi. That would be the whole circle again. But according to my data, right up here, I only have 1/5 of the circle, which means I need to divide it by 5. If I was to divide this by 5, I would get 5 pi, which is the same thing as our multiple choice down here, which would be letter B, 15.7. Now, if this last question just was too insane for your brain to handle, I can appreciate that and understand that. Know that we will spend some more time doing some more examples in class, because this is a very higher level thinking problem. We won't spend a whole lot of time on the test regarding this, but we will see this on the MCAs, and it's important just to know and just be able to think outside of the box on how I might solve something like that. All right, in summary, there's a lot here, so please pause as you go through, because I'm just going to read through them. When I'm asked for circumference, I need to know that I can just use the formula, and that the formula equals 2 pi r, or diameter pi. I need to know that the diameter or the radius, that I can, if I have to find the diameter or the radius, that I'm going to need to use the railroad tracks and undo the formula for 2 pi r. I know that if it wants it to be in terms of pi, I better have pi in my answer. Not the word pi, but the symbol pi. If it says to solve in terms of pi, I better have that symbol. Last but not least, if it's asking for area, and it's asking me just to find the area, I need to use the formula. If it's asking me to find the diameter or the radius, I need to use the formula, but plug in the value of the area and then undo the railroad tracks and take the square root in order to solve for the radius, and then double it for diameter. If I have to find the area of the shaded region, I find the area of both and then just subtract. And if I need to find it in terms of pi or an exact answer, once again, I need to make sure that I have pi in my answer. This is a pretty heavy, deep, note intensive, but if you just stick with those two formulas and plug in the data you know, it's really not that bad.